Hi, my name is Alex Huang. This is the presentation for the final project of E63 Big Data Analytics 2015. The topic of this final project is weather-based flight delay prediction model. So the objective of this project is to look at future weather day and try to predict flight delay. The reason behind that is because airport flight delay is critical to airline operations. The project aims to predict airport flight delay based on the following three feature types. First of all, weather condition at an airport. Second, flight delay, flight departure and arrival demand. And also the third one, which is the airport departure and arrival capacity. We focus this analysis mainly at an airport, and we recognize that there are weather events other than airports that will have impact on flight delay at an airport. However, let's assume that in this case, we only focus on the airport. And then, based on this information, why it is important? It is critical for the airline to be aware of the future condition at an airport, because they will know that whether there is a delay impact at the hub airports, and also they want to know the magnitude of such impact based on weather, flight, and capacity. Because airlines will be able to get better situation awareness, knowing that there might be some potential delay at this airport based on the weather prediction as well as based on the airport demand. And then so that they know if an airport is gonna encounter delay, they're gonna be able to set stage of the operations for potential disruptions. And then they can focus attentions and resources at airport predicted to have major delay impact. The flow of this data analysis process is that first of all, we acquire data from the FAA website, and then it divided into two parts. The first part is the normal machine learning data analytics, focusing on single airport. In this case, we do data preparation, we do machine learning using random forest, and machine learning using decision tree. And then all the analysis in this part is done using Python, IPython, Pandas, and scikit-learn within Python. And then this focus mainly on an airport data. Each airport is a single model. The second part of the data is more of a big data analytics, which focus on the national airspace system, which means we assume all airports are homogeneous, meaning that they are the same. And let's look at how the weather prediction as well as flight demand and capacity will have impact on the delay at an airport, assuming all airports are homogeneous. And we'll do data preparation, machine learning random forest, and machine learning decision trees. And this is done using IPython, Pandas, and also Spark ML Lab, which is machine learning library. And then it's all based on the Hadoop infrastructure. The technology used, as I mentioned, the analysis leverages the following software applications: Python and libraries, NumPy, Pandas, scikit-learn, and also IPython, Hadoop, and Spark. The environment. The data set that we use is a 2014 data set. It contains all 29 domestic United States airports weather information as well as flight information. The frequency is every quarter hour. So that means every day each airport will have 4 by 24 rows of data. And then the data field contains 83 data fields. The total data record is close to 700,000 records. The data size is 866 megabyte. We run this on the 8 gigabyte i7 MacBook Air, a single machine, and we use, as I mentioned, IPython. The infrastructure we use is we build a Hadoop cluster on this MacBook, and then we build Spark on top of it. And then we have IPython as the um, interface language to call this Hadoop and Spark beneath the IPython shell. So the analysis model, as I mentioned, the project contains the following model. First of all, single airport model. We create two type of parameters or models within that single airport model. One is a simple model. The second one is a complex model. And we do the same thing for the National Airspace System model. So for single airport model, as I mentioned, Python package and scikit-learn libraries are used. For the national airspace model, we use this big data analytics environment to conduct the analysis and machine learning approach. And then the problem is a supervised multi-class classification problem. And then we use two machine learning method, random forest and decision trees. Because this is multi-class, so sometimes we cannot do the binary classification. So the result. Before we go to the result, let's look at the code. In the code, what we have is this is the IPython process, and then at the very beginning, we look into importing all these required libraries in the Python, and then we reading the data into a pandas database within IPython. And as you can see here, we have 29 airports in the United States. And the number, the month is last year, 2014, from January to December. And what we did is we used Boston as an example. First of all, we fill the data into Boston airport, and then it's around 24,000 records, and then contains 83 data fields. And then here is a list of data fields here. And once we get the data, this is a subset of data we'll be using for this analysis. We do data cleanup. The data cleanup contains the following information. First of all, we only take a subset of data that we think are totally relevant to the analysis and exclude the others. And then once we did that, based on that subset of data, we further create additional fields or features that I think that's a more relevant, or try to combine data fields to create a better feature that we think will be used. At the end of the stage, as you can see here, we also look into this TOD, time of day indicator. So if a flight, if this record is like 8 o'clock in the morning versus 10 o'clock in the evening, what we do is we try to separate those into different bin of the time of day. So at the end of this process, as you can see here, it's for each raw represent a quarter hour data information on both weather as well as flight demand and flight capacity from the historical data. And then what we do next is we try to do some data wrangling, and at the end, we further take a subset that we think are more related to the analysis. So toward the end, this is the data that we're looking into for Boston. And what we want to do is, as you can see here, is to transform what we want to do next is to transform data. We transform data by converting the data and then use the group by the date, by time of days. So what we did here is we transpose the data. Again, is toward the end, we want to make sure that each day is a record, contain different TOD, time of day information. So this is the result. We did data transformation from for each record to go from a quarter hour record to a 1 day record. And those are the data fields that we're looking into. And what we do next is we save it into a CSV file and read it again. And then this is the data field. which contains of demand, capacity, wind direction, wind speed, and temperature, and also MC, meteorological condition, which is how many flights an airport can take per hour based on the weather condition. So those are the records here. And then what we do next is to create different models. We look at departure and arrival. We try to predict departure and arrival differently. Departure, simple model, complex model, and also arrival, simple model, and complex model. What we do here is once we finish those feature list, as you can see here, we do all the data cleaning up. We start doing the random forest analysis. We prepare the data, do the random forest analysis. Right here, we see the departure delay using a simple model. The result is close to 65% of accuracy rate. However, if we look at a complex model, the result improve to close to 70%. And on the other hand, this is a list of features that importance of each feature that which is relevant. Here we think that the ratio between demand and capacity ratio are the critical ones. And then also we look at the arrival, which as you can see here, the prediction accuracy for arrival is a little bit higher, maybe around 5% higher for arrival than departures, at least for Boston. And then once we complete that analysis, as you can see here, we did some confusion matrix. And then toward the end, what we want to do is we want to look at the single airport flight delay due to weather prediction. Let's look at the NASWIPE model. So first of all, we take one airport and then use Spark to conduct analysis. So this is the random forest analysis for one airport. So it's not a lot of data for one airport because it's 365 days for last year, but we still use it. However, we know that this is not large enough. So what we do is we use all airport data. We assume all airports are homogeneous, irrelevant to any other factors, which is a little bit is a strong assumption. I understand that. However, what we try to do is we try to do analysis using big data. So after doing all this data analysis or data preparation, like what I did before, here is the model delay using simple feature models, and then we assuming that we after we did all this normalization and everything, as you can see here, this is use random forest class modified. This is used Python scikit-learn to run the result. It took around 7 minutes to complete all this, and then we did similar analysis for using Spark ML Lab, and then the accuracy rate, as you can see here, the error rate is lower compared with the one that done in the scikit-learn. However, we didn't really do the actual timing. It's take a little bit longer. And then yet we did analysis. This analysis tried to look at the difference in terms of number of random tree that is created. And then the second one is let's look at number of level. That how many level we want to go deep down to get a better result. As you can see here, roughly around 4 will give us the better result. And then going back to the original analysis, we see the result. As you can see here, the complex model, single airport model will get better result than the NASWIPE model. And then also the complex random forest model is better than the simple random forest model. The improvement is around 5%. And as you can see here, is using Spark ML Lab. The random forest model yields lowest test error rates when modeled with at least 20 or more trees. And then the last one is for the machine learning lab, decision tree model seems to have better accuracy rate with the tree depth of 4. Lastly, we did a quick technology comparison, and what we believe is that using the same random forest machine learning approach, Spark ML Lab seems to yield better result compared against the scikit-learn library. However, in terms of efficiency, the result is not as good in terms of the time. We believe this is because we're running on a single machine. If we start running a cluster, we can leverage the parallel processing from different machines to get better result.